We're talking C++ versus Rust, and this isn't just some nerdy squabble. It's a battle of philosophies that could seriously define the future of the code that runs, well, pretty much our entire world.
To really get this, you gotta start with the philosophy of the reigning king, C++. And who better to hear it from than the man who created it, Bjarne Stroustrup. This quote right here, it's everything. It tells you that from day one, C++ was built to put power first. It trusts the programmer, like, completely. It gives them total control, even if that means leaving in features that are, a little dangerous. That freedom is its greatest strength, but as we're about to see, it's also its greatest vulnerability.
Alright, so let's properly meet the first character in our story, C++. For decades, and I mean decades, it has been the undisputed king of performance. It's the language behind the fastest, most complicated systems you can possibly imagine. And just look at this timeline. It really shows you the sheer staying power of C++. This is not some dusty old relic. It's a living, breathing language that has been changing and adapting since 1983. From taking over the world in the 90s to getting huge modern updates in the 2010s, it is still at the absolute cutting edge, with massive global conferences like CPPCon pushing it forward even today.
Okay, and this slide, this just lays out the core conflict perfectly. On one side, you have C++, which basically says, hey, I trust you, the programmer. Performance is everything. You handle the memory. But then Rust comes along with a totally different take. Whoa there, let the compiler help you out. Safety is everything. We're going to enforce memory safety so you literally can't make those critical mistakes. This right here is the fundamental divide we're going to be exploring.
But, that whole C++ philosophy of programmer freedom, well, it comes with a pretty big price tag. For decades, there's been this hidden flaw that's been responsible for just a huge number of security problems and system crashes. So let's talk about the high cost of all that freedom. And that flaw has a name, memory unsafety. So what is that exactly? Well, to put it simply, it's when a program accidentally messes with a piece of the computer's memory that it's not supposed to be touching. Now, this can just cause the program to crash, which is annoying, or much worse, it can create a security hole that hackers can get through. This is the technical problem at the very heart of this whole debate. And look, this is not just some abstract, nerdy problem for programmers. It has massive, real-world consequences. In 2023, Consumer Reports, the same people who review your toaster and your car, they published this report. They basically reframed memory unsafety as a consumer safety issue. That's when you know this thing has gotten really, really serious. So, now that we've established the problem, the stage is perfectly set for our challenger to walk in. Enter Rust, a modern language built from the ground up to preach what you might call the gospel of memory safety. And you gotta understand where Rust came from. It was created at Mozilla, the company behind the Firefox browser, with a super specific goal, to be a better C++. The whole idea was to give developers all the raw power and performance of C++, but with one game-changing promise, guaranteed memory safety. So how on earth does Rust pull this off? It's through its most famous and revolutionary feature, the ownership model. And it's enforced by something called the borrow checker. Let's break it down real simple. First, every single piece of data has one and only one owner. Second, when that owner is done with it, the memory is automatically cleaned up for you. And third, the compiler acts like a super strict librarian. It enforces all these rules about borrowing data to prevent any dangerous situations. If you break the rules, your code just won't compile. Period. Now that's the trade-off. Learning these rules is famously tough, which is where Rust gets its reputation for a steep learning curve. But the payoff, as you're about to see, is absolutely immense. Okay, that all sounds great on paper, right? But does it actually work in the real world? So let's head over to the proving grounds, Google's Android operating system, one of the biggest and most complex code bases on the entire planet. The results from Google's experiment are, well, they're staggering. The bottom line is this. For new code written in Rust, they saw a 1,000 times reduction in the density of memory safety bugs compared to the C and C++ code. Let that sink in for a second. 1,000 times. That's not just an improvement. That is a